Okay, final multiple choice question. Another property question. We have the graph of f shown to us, and we are asked to determine the integral from -1 to 9 of 3f of x plus 2 dx. Okay, so in the previous problems, they told you that the integral from -1 to 9 of f of x dx was equal to some number. Okay, that's not the case here. Here's the case where we actually have to figure this out, and once we figure out this definite integral, then we can attack the more complicated integral involving f. All right, so what is this equal to? Well, this is equal to the combined areas of the regions between the function and the x-axis. So what are we looking at? Well, here's -1, and here's 9. So we're looking at this trapezoid, and we're looking at this triangle. All right, well, this trapezoid, you can actually see we have 1, 2, 3 square units, and then we have a half a square unit. Okay, so this trapezoid right here, all right, that's going to work out to -3.5. And remember, we need the negative because this trapezoid is below the x-axis. Here we have a triangle. The height of the triangle is 2. The base of the triangle goes from 3 all the way to 9, so that's a base of 6. All right, so our area is 1/2 2 times 6. So we get 6 up there. So we have 6 positive, -3.5 negative in the negative area. So the integral will be the sum of those two numbers, 6 and -3.5. All right, so the integral from -1 to 9 of f of x dx is 2.5. Okay, so now we're going to take this idea and we're going to put it into this integrand. Let's break this up like we've done with previous problems. All right, we have the integral from -1 to 9. We can move the 3 out front. We have f of x dx plus the integral from -1 to 9 of 2 dx. All right, so we have 3 times the integral. We know that we have 2.5 here. So this is 3 times 2.5, which is 7.5. Get up a little bit. There we go. Hence the reason why we have option A. Okay, then we see the plus 2. If we add 2 to that, we would get 9.5. All right, remember, we don't want to do that. We want to do 2 times the range. 9 minus -1 is 10. So we're adding 2 times 10, which means we have to add 20, which means we want C. All right, flipping over to the free response question. We've got a test plane flying in a straight line. Positive velocity. I love how they say straight line. All lines are straight. All right, positive velocity, miles per minute at time t minutes. V is differentiable. That's going to be important later on. And then they tell us that they've given us certain values of V in this table above. All right, option A. Let's see if I can slide up slightly. Let's do a midpoint Riemann sum. 4 subintervals, equal length, to approximate the integral from 0 to 40 of V of t dt. So we got to get from 0 to 40, and we have to do it in 4 subintervals. So we can obviously see there we're going from 0 to 10, 10 to 20, 20 to 30, and 30 to 40. And we want the midpoint of each of those regions. All right, so that means we're going to be focusing on the 5, the 15, the 25, and the 35. And specifically, we're going to be focusing on the velocities at those spots. All right, so the first height of our rectangle will be 9.2. So we're going to have 9.2, and we're going to multiply that by the base. And the base goes from 0 to 10. It's multiplied by 10. All right, now we go to our second rectangle. And we're going to use the 7. And we multiply that by, multiply, so there we go. All right, now we go to our third rectangle. We're going to use the 2.4. And we multiply that by the base, which is 10. And finally, 35 has a value of 4.3. So multiply that by 10. Okay, now on the exam, you can stop right here. This is good enough, okay? Yeah, you can do the math out because we're just multiplying by 10. So what we're really looking at here is 92 plus 70 plus 24 plus 43. And so we have 162. We add 24 to that, and we have 186. And we add 43 to that, and we have 229. Okay, so that's what the midpoint sum comes out to. Now, using correct units, explain what it is that you just found. What is this 229? Well, this is a velocity function. So remember, the area under this curve represents the total distance traveled. All right. So we know that the plane flew approximately 229, and remember it says using correct units, 229 miles during the first 40 minutes of the flight. Okay, it's important to, yeah, it flew 225 miles, but when? Well, from time t equals 0 to t equals 40. We have to mention the time interval, those first 40 minutes. Could have also said during time t, from time t equals 0 to time t equals 40. That would give us the same answer, but this is just saying it in English. Okay, part 2. Based on the values of the table, what is the smallest number of instances at which the acceleration of the plane could equal 0? Okay, acceleration. We weren't given acceleration, we were given velocity. All right, so what's the connection between velocity and acceleration? Yes, acceleration is the derivative. So we're being asked about the derivative velocity, even though we weren't given the derivative of the velocity. So if that comes into play, guess what we need to think about? Mean value theorem. Okay, mean value theorem comes into play if our function is differentiable. Hence the reason why it was very important that they told us that word up there in the stem of the question. So our function v is differentiable, which means that the mean value theorem is into play. We want the derivative to be equal to 0. We want the I'm just going to write the derivative of this velocity function. All right, let's scale it. We want the acceleration to be equal to 0. Okay, well that acceleration is v prime. So we're interested in how many times will v prime be equal to 0? Well, we have to do, if you recall, for mean value theorem, we need to do the average rate of change. So v of b minus v of a over b minus a. We want to know, when is that equal to 0? Well, when is a fraction equal to 0? Right, when the numerator is equal to 0. So we need two velocity values that will be equal to each other. Because if the velocity at b is equal to the velocity at a, then v of b minus v of a will produce that 0. Let's go to our chart. Do we see a pair of velocity values that are the same? I do. See them here and there. All right, so if the velocity is 7 miles per minute at time 0 and 7 miles per minute at time 15, 7 minus 7 over 15 minus 0 will give us 0. Where else do you see a pair that match up? Exactly, here. So if we were to do an average rate of change, we'd do 2.4 minus 2.4 over 25 minus 30, 30 minus 25, doesn't matter. We get 0 there as well. We're getting the derivative equal to 0 based off of the average rate of change. So it happened twice. So we're going to say 2 times. All right, justify your answer. Okay, 2 times, since the average rate of change of the velocity over our first interval was from 0 to 15, and our second interval was from 25 to 30. So since the average rate change of the velocity over this interval and that interval equals 0, and the mean value theorem. Okay. All right, I'm going to pause there because I'm about to hit the recording limit. We'll do the last 2 parts in a final video.